For the remainder of the lesson, we're going to be dealing with rational functions, aka fractions of polynomials. Rational functions can be positive, negative, undefined, or zero. A fraction that equals zero is only when the numerator is equal to zero, and a fraction is undefined when the denominator equals zero. Always use parentheses when the fraction is undefined, because that means that I cannot actually include that value that we're going to get from these factors. All right, so for these reasons, both the numerator and denominator values both need to be included in our sign charts. So making a sign chart for g of x is equal to 3x plus 1 all over x minus 1 times the quantity of x plus 3. So again, I'm going to make my sign chart. My value from the numerator, well, if I set that equal to 0, solve for x, I'm going to get negative 1/3 for my x value, and then my solution to this part should just be positive 1, and my solution to this part should give me negative 3. So those are my three values that go on my sign chart. Okay, from here, I pick a number that comes before negative 3 to go over here. So picking a number that goes before negative 3, let's pick negative 4 for instance. So plugging negative 4 into x here, overall, I would get a negative for the top portion over. If I plug in negative 4 here, and for x, negative 4 minus 1 gave me negative 5, which is overall negative. And if I plug in negative 4 here, I was going to get a negative here as well. So then I have a negative divided by a negative, which is still positive, and then times a negative would give me a negative overall. All right, now I plug in something in between negative 3 and negative 1/3. So for example, negative 1 would do. Plugging in negative 1 in for x up here would give me a negative overall. Plugging in a negative 1 here would still give me a negative overall in that factor. And then plugging in a negative 1 here would actually give me a positive. So then I've got a negative divided by a negative, which will give me a positive, times a positive, which will overall give me a positive number. Okay, plugging in something in between negative 1/3 and 1, and for this section, all right, plugging in 0 is probably the easiest, so that'll give me a positive up top over a negative and a positive. So overall, this whole piece is going to be negative. And then finally, for this piece over here, I'm going to plug in something after 1. So plugging something in after 1 up top will get me a positive. That next little factor will give me a positive, and this next little factor will also give me a positive. So overall, this whole graph should be positive there. Positive meaning my y value. So answers to the following inequalities using our sign chart. So it says find the values of x so that this whole equation is less than 0. So less than 0 just means, hey, my y values are going to be below my y-axis, otherwise known as they are going to have a negative sign on my sign chart. So those intervals are from negative infinity to negative 3 and negative 1/3 to 1. And that's it. Again, they have parentheses because at 0, where this might be 0 crossing the positive to negative or negative to positive, we cannot include that this time. All right, because not or equal to. All right, find the values so that 3x plus 1 all over x minus 1 times the quantity of x plus 3 is less than or equal to 0. Well, that'd be very similar. It's still where it's less than 0, so I definitely still have to include these values again. So from negative infinity to negative 3, but this time I can include things that actually make me equal 0. However, that negative 3 came from my denominator, which means that that would be undefined at negative 3. So I can't actually include that this time, which is kind of unfortunate. And then after that, I would say, okay, well, then that's cool. I also have this negative 1/3. Well, negative 1/3 actually came from the numerator, which means that my function would actually equal 0 when the numerator is equal to 0. So negative 1/3, I can actually include all the way to 1. Well, 1 came from my denominator, making that undefined, so I can only put a parenthesis there. Alright, so now what about find where the function is greater than 0. So greater than 0 definitely means that I am looking where my values are positive. My y values are positive. which on my sign chart just means that I have a big old plus sign. So that would be between -3 and -1/3. Again, if it's not or equal to bar, I don't even have to worry about putting parentheses or brackets. They should just be parentheses in most cases. And then union with 1 to positive infinity. Okay, and infinity is never included again. All right, and then find values that the function is greater than or equal to 0. So I still have -3 to -1/3. But again, now I got to be careful which one I'm including. So this -3, again, came from my denominator, which would say that, hey, that's going to make that undefined. Undefined, we always use parentheses for. And then that -1/3 came from my numerator. Well, that's when my function would equal 0. So therefore, it could be or equal to there. And then union with, where else is it positive? 1. Well, 1 again came from my denominator, which is why I subconsciously already put a parenthesis, because if it comes from the denominator, that's when the function is undefined. And so therefore, I have to put a parenthesis there all the way to infinity. And then I would be done. It's great.